All right, let's practice continuity. So in example number 1, it asks us to determine if each function is continuous at the indicated x value. So let's look at each graph, figure out if it is continuous, and if it's not continuous, what rule is broken and what kind of discontinuity does it have? So looking at A, is this graph discontinuous or continuous at x equals 3? Well, you may notice at x equals 3, there's a hole there in my graph. If you were to trace, you'd have to jump over the hole in order to keep going. So I would say that this graph is discontinuous. Now, what type of discontinuity does this graph have? Removable or non-removable? I would say that this one has removable discontinuity at x equals 3 because there's just one little hole there. Removable discontinuity. Now, if I'm looking back at my three things that I need in order for a function to be continuous, those three criteria, which one of the three criteria is not met because it's discontinuous? So let's go through each one. For the first one, is f of 3 defined? Is there a value along x equals 3? Well, because there is no value, there's only open space there, open dots, I would say that the first rule is not met and f of 3 does not exist. And because that first rule is not met, well, we know automatically then that our function is discontinuous. F of 3 does not exist. Looking at B, is this function continuous at x equals 0? Well, if you were following the path, wouldn't you have to jump all the way up here before you continued? So I would say that this function is also discontinuous. Would you say it's removable or non-removable discontinuity? Well, because there's a big old gap, I would say that this is non-removable discontinuity at x equals 0 because there's a big old gap. You can't just plug it up with one dot. So let's go through the rules again to see which rule or criteria is not met on this discontinuity. If you look at rule number 1, does f of 0 exist? Well, if I'm looking, f of 0 does exist. Isn't there a value down here? There's a dot at -1. So rule number 1 actually works. F of 0 is defined. It's -1. My second rule says, does the limit as x approaches 0 exist? What is the limit as we approach 0? Well, remember, limits are following the path. So if you're coming from the left and I'm coming from the right and we approach 0, are we going to be together? Nope. I'm up there at 1 and you're down there at -1. So the limit does not exist. And that's what makes this function discontinuous. Rule number 2, the limit as x approaches 0 of f of x does not exist. You notice that I didn't just say there's a gap or rule number 2. You notice that I wrote out the rule using proper notation. The limit as x approaches 0 of f of x does not exist. I want to go back real quick. I was just thinking about example number 1a again. Remember, f of 3 did not exist, rule number 1, and then I stopped. Well, if I was trying to look at the other rules and I looked to see if the limit as x approaches 3, if you're following the path from the left and I'm following the path from the right, aren't we going to be together at 2? So actually the limit on this one, the limit as x approaches 3 of f of x does exist, it's 2. So rule number 2 actually works, right? And so as soon as I see the first rule not working, that's the rule I know it's going to be. Okay, let's go down and do 2 more, C and D. Looking at C, is this function continuous at x equals 4? Well, I know that as I'm following the path here, I would have to lift up my pencil as soon as I got to the hole and then continue to go because there's a hole there. Okay, so this would be discontinuous. Well, what type of discontinuity is it? Well, because there's just a hole, this is removable discontinuity. I could plug it up with just one dot. So removable discontinuity at x equals 4. Okay, it's still discontinuous, so which one of the 3 criteria is not met? Let's go through. Is f of 4 defined? Well, when I plug in 4, I actually do get a value at this dot up here at y equals 1. So f of 4 is equal to 1. It does exist, so rule number 1 works. Is there a limit as x approaches 4 of f of x? Well, if you're following the path from the left and I'm following the path from the right, we do end up meeting up. Even though Starbucks is closed, we can hang out there at -2. So actually rule number 2 also works. However, rule number 3 says that those two things have to be equal. And since they're not, then that's why it's discontinuous. The limit, as x approaches 4 of f of x, does not equal f of 4. One of them was -2, the other one was +1. That dot didn't plug up my hole, so rule number 3 is the one that wasn't met in order to prove continuity. All right, last one. Is this one continuous at x equals -2? You may notice at x equals -2 there's a vertical asymptote, right? And so that causes discontinuity. And because we can't just plug up a vertical asymptote with one dot, it is non-removable discontinuity at x equals -2. Which one of the 3 criteria is not met here? Well, if I start at number 1, f of -2 doesn't exist because there's a big old vertical asymptote there, right? And so I would say that f of -2 does not exist. Rule number 1. And as soon as rule number 1 doesn't work, then I know my function is discontinuous. None of the other rules even matter.